Okay, so we are going to talk about hypothesis testing for population means when our population standard deviation is unknown. Okay, now remember, when the population standard deviation is unknown, we will use a T for our test statistic. We will be using the student's T distribution table. And remember, our formula for T is our sample mean minus the population mean divided by the sample standard deviation over the square root of n. Okay. Our steps to complete the hypothesis test is very similar. We have the null and alternative hypothesis. We'll decide on our student's T distribution. We'll need to find that level of significance. We'll find the value of the test statistic, and then we'll draw a conclusion. For our conclusions in this section, we will only use our rejection regions. Okay, so we will use our rejection regions. One thing about this, if it is a left tailed test, okay, so if in that alternative hypothesis we have a less than symbol, some value there, we will need to make the critical value negative. All right, on our table that we have for the critical values, they are all positive. But if something's a left-tailed test, we'll just throw a negative sign in front of it. Okay. All right. About that table, let's just talk about it real quick. Okay, we have a two-tailed test right here. We will use that when, let me go back to that Word document. All right, we will use the two-tailed test when the alternative hypothesis uses a not equal to symbol. Okay, we will use a one-tailed test if that alternative hypothesis uses a less than or a greater than symbol. And if it's a less than symbol, we will need to make that critical value negative. Okay. All right, so here we go with our first example. We have a cable company claims it has excellent customer service. The company advertises that a technician will arrive in approximately 30 minutes after a service call is placed. A frustrated customer believes this is not accurate, claiming that it takes over 30 minutes for the cable technician to arrive. All right, we have a simple random sample of 9 cable customers. The sample mean was 33.2 minutes, and our standard deviation is 3.4. We're using 0.025 level of significance. All right, so here we go, our null and our alternative hypothesis. Okay, our null hypothesis is that we equal 30, and our alternative is that it's greater than 30. Okay, we're going to use student T distribution. Since we know a sample standard deviation, this is coming from the sample. All right, and this is a right-tailed test. When we use our table for that student's T distribution, this is a one-tailed test, and our level of significance is 0.025. Okay. All right, we're going to calculate the test statistic. So we have T equals our sample mean minus our population mean over our sample standard deviation over the square root of n. All right, so this should give us 2.824. This is our test statistic right here. Okay. All right, now we need to draw that rejection region. So we need to find a critical value. All right, since n is 9, our degrees of freedom is 8. Our level of significance is 0.025, and this is a one-tailed test. So let's see if we can't look at our table and find the value that we need. All right, so this is a one-tailed area of 0.025 right here. All right, degrees of freedom is 8. And we have a one-tailed test, so I'm going to say 2.306 right here. Okay, 2.306. All right, our test statistic, 2.8, lands right here. So we're going to reject the null hypothesis. Okay. All right, next example. All right, a parenting magazine reports that the average amount of wireless data used by teenagers each month is 10 gigabytes. For her science fair project, Ella sets out to prove the magazine wrong. She claims that the mean among teenagers in her area is less than reported. Ella collects information from a simple random sample of 25 teenagers at her high school and calculates the mean of 9.8. And we have a standard deviation of 2.7. All right, so our null hypothesis is that it equals 10. And the alternative, she's trying to prove it's less than 10. Okay. All right, so we're using students' t distribution. All right, since we know the sample standard deviation. This is a left tail test. So remember, we will need to make that critical value negative when we draw our rejection region. Level of significance is 0.01. All right, so our test statistic, we have our sample mean, let's see, 9.8, minus our population over our sample standard deviation over the square root of n. Oh, I didn't mean to put a z there. This should be a t, excuse me. All right, so this is going to give us a negative 0.37. This is our test statistic. All right, we need to draw our rejection region, so we need to find that critical value. Let's see, we got a one-tailed test. Our level of significance is 0.01. N is 25, so our degree of freedom is 24. All right, so let's see what we got here. Degrees of freedom is 24. One-tailed test, 0.01. So I'm looking at 2.492. And since this is a left-tailed test, I'm going to make that negative. All right, so this is our rejection region here. Our critical value actually falls right here. So this time we will fail to reject the null hypothesis, which means we actually support what the null hypothesis is saying, and we would say that the information of this 9.8 gigabytes per month is not statistically significant.